Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to build a serverless GenAI solution to create call center transcript summary via REST API, Lambda, and AWS Bedrock Converse API. I have posted a similar video before using Amazon Bedrock Invoke Model API. However, as of May 2024, AWS has announced a new Bedrock Converse API, and I have updated the API and Lambda function code to call the foundation model using this Converse API. Amazon Bedrock is fully managed service that offers choice of many foundation models like Anthropic Cloud, AI21 Jurassic 2, Stability AI, Amazon Titan, and others. I will use recently released Anthropic Haku foundation model and will invoke it via Amazon Bedrock Converse API. There is no business that can work without having a customer support center, usually referred as call center or care center. When customer calls to get answer for their questions or to get resolution for their issues or a warranty support feedback, etc., typically a call recording and transcript with an acknowledgement gets placed in the system. These call recording and transcripts can be used later to train customer support center staff and to improve customer service. However, consuming these call transcripts can be very time-consuming process. Generative AI-based solution can help accelerate consumption of these transcripts by summarizing the narrative from these transcripts. This will help increase productivity, save time, and speed up actions to improve customer service, making a positive impact on the business. Let's look at our business use case. There is a transcript available for a case resolution and conversation between customer and support call center team member. A call summary needs to be created based on this resolution conversation transcript. An automated solution is required to create call summary. An automated solution will provide a repeatable way to create these call summary notes. Increase in productivity as team members usually work on documenting these notes can focus on other tasks. I will be creating the Lambda function via infrastructure as code approach using AWS Serverless Application Framework and CloudFormation. However, you can create the Lambda function using the AWS console as well. Let's look at our architecture pattern. We have a user or a consuming app that is invoking a REST API that's being served by AWS API Gateway. API is taking call center transcript file as a parameter, which is served as a prompt and passed to the Lambda function. Lambda function is invoking the Bedrock, specifically Bedrock Converse API, and underlying API model. In this particular case, Anthropic Haku is that what we are invoking. Because Converse API supports multiple model, a consistent way to invoking multiple model, we can also use the same code to invoke Anthropic Sonnet or Amazon Titan or other models. Prereq for this workshop is simply familiarity with AWS console. We need a transcript of resolution and conversation between customer and support call center team member, knowledge of Python Boto 3, knowledge of AWS Lambda, basic familiarity with generative AI and foundation model concepts. Let's get started. We're going to review our Bedrock service. We'll do a quick review of Converse API. We'll review foundation models, request model access, look at the playground, review some key terms like temperature, top P, max token count. We'll review the AWS SAM template and the Lambda function code. We'll build the function using AWS SAM, and then we'll invoke it locally using AWS SAM. Once it's deployed, then we can validate the GenAI model using a prompt. We'll use Postman for that, review the response, review the CloudWatch log. Like I stated before, I'll be creating it as infrastructure as code approach using the AWS SAM, but the same function can be created using AWS console as well. So let's quickly look at Bedrock service. Amazon Bedrock is fully managed service that offers choices of many foundation models like Anthropic Cloud, AI21 Jurassic 2, Stability AI, Amazon Titan, and others. Since Bedrock is another serverless offering from Amazon, it allows integrating with popular foundation models and also allow to privately customize foundation models with your own data using the AWS tools without having to manage any infrastructure. Why Bedrock Converse API? You might be wondering why there is need for another API when Bedrock already supports invoking model for large language models. The challenge that the Converse API aims to address is the varying parameter required to invoke different large language model. It offers a consistent API that can call underlying Amazon Bedrock Foundation model without requiring changes in your code. For example, your code can call Anthropic Haiku, Anthropic Sonnet, or Amazon Titan just by changing the model ID without needing any other modifications in the code. While the API specification provides a standardized set of inference parameters, it also allows for the inclusion of unique parameters when needed. As of May 2024, the newly introduced Converse API does not support embedding or image generation models. Here is a look at choice of foundation models. Like I stated before, there is Anthropic, Amazon, Cohere, Meta, Mistral, Stability AI, AI21 Jurassic Labs. These are all different models. Within Anthropic, there are family of models, Haiku, Sonnet, Opus. There is a recently released Sonnet 3.5 that just got announced. So there are a lot of choices here. I'll be using Anthropic Haiku for this workshop. Before model can be used, you need to request the access to the model. So you go to your console, select the model and request model access. Typically for Amazon model, it takes few minutes to get access. For Anthropic and few other models, it may take from few minutes to few hours to get access. AWS Bedrock also provide a playground where you can pass the prompt, you can adjust the inference parameters, and you can review the response. However, I will not be using the playground. Rather, I will use Bedrock API to provide prompt and get the response. Temperature, top P, max token count are some of the common parameters used by most LLM. Temperature is a value of 0, indicate less random generation. Value of 1 means more random generation. Top P, if value is less than 1, it will have less probable set of tokens. And then max token count, this indicates max number of tokens to generate. Responses are not guaranteed to fill up the maximum desired length. Tokens are factored in the overall cost, hence it's worthwhile to pay attention to max token you want to use for your specific business use case. Let's look at our AWS SAM template. It's a serverless application model. So you will look at, if you are familiar with SAM, you will see that I have a couple of resources here. The first set here is talking about an REST API resource, and I'm using a stage named dev. It's a regional type endpoint. Main thing here is a Lambda function. So I have a function called call center summary creator function. Its runtime is Python 3.12, timeout is 120 seconds. I'm using a default memory size of 128 MB. I'm using environment variables so that I can change the value without changing the code. So I can pass the model ID, I can pass my token count, temperature, and other parameters. Let's look at the Lambda function code here. So this is a partial Lambda function code. The full code is posted in the Git repository. So let's look at the code here. So I have a generate conversation function, and I'm building my inference config by having the max token, the temperature, the top P, and sequence here. I'm building that, and then I have a unique situation for Amazon Titan that it doesn't support the one of the parameters and also the system prompt. So I have a if block for that, and then I have an else block for Anthropic model support. And once I do that, then I also have another function to build a response that it will be sent back to the consumer via the API. Here is like some subtle differences between Bedrock invoke model versus Bedrock Converse API. So let's review the differences. If you see like the Bedrock invoke, we have to build a prompt body, and then that has like our message and all different parameters like token, sequence, temperature, etc. Also in the response in the client runtime, we have to invoke model function and then pass the model ID and the prompt body in that API call. On the other hand, for the invoke API, we create and build a inference config using the max tokens, temperature, and other parameter. And then in a client runtime, instead of invoke model, we are passing converse, which is abstracting the implementation of inference config and other parameters for us. So providing us a consistent way to pass the information to the model. So here we have converse, we passing the model ID, the message, the system prompt, inference config, and then if needed, additional model request fields also. One thing to note here is that since it's a fairly new offering from AWS, it does require Boto 3 1.34.116 or higher. So make sure that you are using that version of Boto. Let's build the function using AWS SAM. So command to build a SAM build. Once you see build succeeded, you're ready to invoke the function locally, and the command for that is SAM local invoke and the function name, and then you can pass your payload in a JSON format. Once function works as per your expectation locally, you are ready to deploy this function using AWS SAM, and the command for that is SAM deploy. Once function is deployed and you have an API endpoint, you can actually use a tool of your choice to validate the API endpoint and get the response. I like Postman, so I'm using Postman here, and I'm passing a transcript file for the prompt. Here is my response from the Anthropic Haku. And based on the transcript file, which is a conversation between the call center support person and the customer, it has created a summary of the conversation. And this is around that customer calls for a account locked because of multiple failed password attempts. And customer support person asks a variety of questions, security questions, the account number, and so on. And customer provided all that information and the end result of that conversation. So really nice summary based on the transcript that large language model in this case has provided and back to consumer via the API. Since we are using Converse API, that's the beauty of this API, that it abstracts the underlying implementation. So I can use the same code, same transcript file, just by changing the model ID in my parameter for a different language model. So in this case, same example, same transcript file. When I run it through the same code, here is the response that I'm getting from Sonnet, and also like another example that I'm getting from Amazon Titan. So one API, three large language model I'm able to use without any code change, and that's the beauty and strength of this newly introduced Amazon Bedrock Converse API. Pretty cool. Here is our log, and I have a lot of log messages in the Lambda function. So that's what you will see in the CloudWatch. You can see your event. You can see all the other logs that I have put in the code, and also like printing the response that we are getting from the large language model. So with this workshop, a serverless GenAI solution to create call center transcript summary via REST API, Lambda, and Bedrock Converse API has been successfully completed. Python Boto 3 were used to invoke the Bedrock Converse API with Anthropic Echo. As was demonstrated with Converse API, a consistent approach to invoke the API allows changing the underlying foundation model, a much less code-intensive effort, and we were able to get the response by different model just by updating the model ID via environment variable without requiring any code change. As GenAI solutions continue to evolve, they are set to reshape traditional workflow and drive tangible benefit across industry. This workshop serves as a compelling example of the transformative power of AI technology in addressing real-world challenges and unlocking new opportunities for innovation. Hope you have enjoyed this tutorial. I'm working on some other interesting content on various AWS topics. These will be posted soon. Please don't forget to like and subscribe. Thanks for watching.